Two blowers deliver the same airflow and pressure, yet one fills the room with a harsh tone. The other almost disappears into the background. Is the quieter one quiet simply because its blades curve backward? Not quite. Backward curved centrifugal fans often earn a quieter reputation in pressure-duty HVAC equipment, but blade direction is not a mute button. The result comes from the complete aerodynamic design, the operating point, rotational speed, motor and drive, inlet conditions, structure, and how sound is measured. Start with the sound source. A fan produces broadband noise when turbulence and separated flow create irregular pressure fluctuations. It produces tones when a repeating event passes at a fixed rate, often related to blade passing frequency. The motor and electronic drive can add their own tones. Imbalance, bearings, or a flexible panel can turn vibration into structure-borne sound. Backward curved blades lean away from the direction of rotation at the outlet. In a well-designed wheel operating in its intended region, the blade loading and passage flow can remain more orderly, with less separation and recirculation than the same wheel near stall or overload. Lower aerodynamic loss can reduce one important source of broadband noise. But the label alone proves nothing. Blade count, tip speed, clearances, surface shape, and downstream obstruction still determine the acoustic fingerprint. One equation helps explain the tonal part. Blade passing frequency equals blade count multiplied by revolutions per minute, divided by 60. It predicts where a strong repeating tone may appear, it does not predict the complete sound level. Two fans with the same A-weighted number can still sound very different if one concentrates energy in a narrow tone. Now make the comparison fair. Lock the airflow, static or total pressure, air density, rotational speed or control command, inlet and outlet test category, motor and drive, and acoustic method. Compare at the same operating point, not at maximum airflow, not at different speeds, and not with one fan in free air and the other behind a filter. Use sound power when comparing the source under defined laboratory conditions. Sound pressure is what a microphone sees at a position, so it changes with distance, reflections, room absorption, and background noise. Record octave or 1/3 octave bands, not only a single dB/A value. That spectrum exposes blade tones, motor tones, and low-frequency rumble that one summary number can hide. Installation can erase a quiet selection. Put an elbow, guard, coil edge, or cabinet wall too close to the inlet and the wheel receives distorted flow. The blades then need uneven air once per revolution, creating tones and extra broadband noise. On the outlet side, a resonant panel or poorly isolated frame can amplify vibration. The fan did not suddenly change type, the system changed its excitation and radiation paths. So use a 5-stage noise audit. First, plot every required airflow and pressure point on the fan curve. Second, choose the diameter and speed that keep those points in a stable, efficient region with margin for filter loading. Third, protect inlet clearance and use a smooth approach flow. Fourth, control mechanical and electrical sources with balance, rigid mounting where required, suitable isolation, and compatible drive settings. Fifth, validate the final equipment at the listener position and keep the frequency spectrum. Consider 2 installations using the same backward curved wheel. In the first, air enters through a generous plenum, the operating point sits in the efficient island, the frame is stiff and the speed is only as high as the duty requires. In the second, a tight elbow feeds half the inlet, a damper forces the fan away from its intended point, and a thin panel resonates. The blade geometry is identical, the acoustic result is not. That is the real answer. A backward curved fan can run quieter because a well-matched design can reduce aerodynamic loss and unstable flow at the required pressure duty. It runs quieter only when the complete fan and system preserve that advantage. For a defensible acoustic review, send Longwell the full duty map, fan envelope, inlet and outlet geometry, speed or control range, and the required sound metric with measurement position. Those inputs reveal whether the solution is blade geometry, size, speed, installation, or all 4.